You can find them throughout the United Kingdom. They're progressive. They're business people. They value proven agronomic knowledge. Nor are they shy when it comes to technology. They are stewards of the environment. To them, enhanced crop performance means greater profitability. These are the farmers that rely on YaraVita. Because YaraVita products are an essential part of an integrated crop nutrition solution, for farmers insisting on increased efficiency and greater crop performance. Whether it's for potatoes or wheat, YaraVita products are formulated from high-quality ingredients and tested globally to ensure enhanced crop performance, even in adverse growing conditions. YaraVita provides a full and precise solution that reliably manages crop needs at different growing stages throughout the season. From large areas to small, by air and land, YaraVita high-quality nutrition enables greater yield for your crop. With a growing world population and the need to produce more food using less resources, YaraVita farmers are well prepared to deliver on these enormous challenges. For them, it's about going the extra mile.
Good morning, everybody, and welcome to our first YaraVita webinar of 2023. Just to introduce myself, for those that don't know me, my name is Phil Burrell, and I am the product manager for YaraVita, our range of foliar nutrients and biostimulants for the UK and Ireland. And today I'm joined by my colleague Stuart Ward from up in Pocklington, and I'll let Stuart introduce himself now.
Good morning, everybody. I'm Stuart Ward. I'm Chemical Development Manager here at Pocklington, so I'm responsible for product development of all the new YaraVita micronutrients biostimulant foliars, and also for continual improvement on the YaraVita range.
So as we go through the webinar, if you've got any questions, then please feel free to type them in the chat box, and then we'll answer the questions at the end of the webinar. The plan today is I will do a brief introduction of YaraVita, what it is and where it fits into our wider Yara UK business. And then I'll hand over to Stuart, who we've got a video of Stuart giving a formulation demo where we go from how we select the right raw material all the way through to the finished product. So you can see what goes into actually manufacturing a foliar fertilizer product. Then at the end, we'll come back on with webcams for a live Q&A. So if you've got any questions, as I've said, please pop them in the chat box. We'll get to them with Stuart at the end. So just as an introduction to YaraVita and what is it? Fundamentally, the YaraVita range of foliar products are part of what we offer as Yara. I firmly believe as a crop nutrition manufacturer, there is no other company out there that can offer the level of advice that we can offer to farmers when it comes to crop nutrition. And I've just given one example of an oilseed rape crop. You know, we can offer advice right from soil analysis through to tissue analysis through to seed and grain analysis. We've got solid fertilizers, liquid fertilizers. You know, we've got tools and services to make sure you're managing nitrogen as efficiently as possible. And the YaraVita range is one small part of that. But certainly, you know, more than ever, the importance to maximize nitrogen use efficiency is key. So in our second webinar in a couple of weeks' time, we'll look more at the agronomics, whereas today we're focusing on what the products are and how we manufacture them. So a bit of history. The YaraVita products actually go back 50 odd years to 1967. There was a company founded at Pocklington up in Yorkshire called Fosin, which some on the call will certainly remember Fosin. Yara Hydro, as it was at the time, acquired some shares in the Fosin business in 1997, And then in 2006, the business became part of Yara, and YaraVita, the name, was born. But it's worth pointing out that the history of the products goes right back to 1967. And you couple that with the lab next door, which some of you will know as Landcrop. That lab was established in 1975. And the business was arguably ahead of its time, because the whole Fosin business was linked up with the lab to look at what's happening with crops and develop products accordingly to maximize crop needs. And if you think how crop nutrition's gone now, very much we're back into that proactive nutritional management. So I think, you know, the whole business was well ahead of its time. And we have a long heritage, and the fact that our production director at Pocklington, it was his father's business. So we still have a very strong link into Fosin. So a lot of history. In 2014, becoming a global site, we established a bigger glasshouse facility and a full training and development centre, because we regularly host overseas visitors, because we are a global site, and YaraVita starts its journey at Pocklington in Yorkshire. So whether it's a product that's being developed for wheat in Yorkshire or Lincolnshire, or bananas or coffee in Colombia, the product starts its life with Stuart and Stuart's team in Pocklington in Yorkshire. In 2014, we moved into fertilizer coatings and seed treatments. However, for the UK, we are 99% foliar nutrition at this stage. I think there will be developments in seed treatments, particularly with biostimulants, as we move forward. Due to substantial growth around the globe, we actually had to open another production facility in 2018. So we currently only have 2 YaraVita plants globally. One is still in Pocklington in Yorkshire. The other one is in Brazil. Currently, that is producing just for Brazil, Brazil being our biggest market in the globe, taking up around 48% of YaraVita sales globally. In 2019, we then expanded into the biostimulant sector, and I think that will be a growing side of the business. If we were having a webinar in 2030, in 7 years' time, I think we'll have a lot more emphasis on biostimulants as we move forward in time. As I've said, yeah, everything that we have here in the UK comes out of Pocklington, and it is a relatively small factory, but this factory is manufacturing product for 70 countries around the globe. But it all starts life just like Yorkshire tea, made in Yorkshire. And for us in the UK, it's great to have the facility on the doorstep, particularly in times of hardship with supply chains. We have flexible production, which is really, really important for us. And just to give you an idea of the UK market is still the 5th biggest in the globe, which, when you think of our little size on our little island, I think that's quite impressive. The only countries that are bigger than us are Brazil, Canada, China, and the US. So, you know, we're proud of our heritage here in the UK, and yeah, we're a very, very important market to Yara. Everything we do with YaraVita is about quality. We don't claim to be the cheapest in the market. We don't want to be the cheapest in the market. We want to be a premium quality foliar nutrition product that works time and time and time again. And part of that is quality control. You know, everyone thinks it's a given, but just to give you an idea that when we select raw materials, we have very, very stringent guidelines that our suppliers need to work to, and Stuart will cover that during the formulation demo. That's the first point. We do a quality control check. When that raw material arrives at Pocklington, before we even use it in the manufacture of a product, we then take several stages of quality control checks out during the manufacture and during the storage of the product. And then the final stage is the 2 bottles you can see in the middle, where we take samples at the end of the production line when the products are filled. Everything is given a batch number, as you can see on the left-hand side on that can of Maize Boost. That's all stamped on, and that gives us full traceability right back to the raw material. On the right-hand side, you can see a picture of a load of samples. The storage room at the quality control lab at Pocklington holds around 30,000 samples. We keep all samples of batch numbers for a minimum of 2 years. With all the quality control checks we put in place, we shouldn't have any issues. However, if we do, we have full traceability, and that is really, really important in what we do, in offering that security and that peace of mind that what you are buying is what it says on the tin and of the highest quality. Ultimately, there's 4 pillars to YaraVita. The products have got to be efficient, and that's efficient for you as users. So that's where we think of concentration. So you need less product to handle, lower application rates, etc. They've got to be reliable. They've got to work in the field. You know, I can show countless graphs time and time again, but the best way of us promoting our products is get people to use them, people talk, and we see continual growth. So they must be working. They've got to be safe. Everything is safety tested before it even gets to the point of field trials. We need to make sure it's safe to the crop and also safe to the operator. And then I've mentioned superior quality, and that goes all the way down to the packaging. Those that use our products know they're very heavy. So if we buy inferior boxes, the handles will break when delivery drivers bring them out on farm. If we put inferior packaging on the can, the handles break when you take it out of the box. That does not indicate superior quality. And ultimately, everything we do is about quality, not price. I'm going to now stop and hand over back to Jess, who's going to play the formulation video, and then we'll be back in around 30 minutes for the Q&A. So any questions, please shout out.
What we have to show you in this session is a practical demonstration to try to illustrate the work that we put into formulating YaraVita and to try to highlight some of the benefits that correct formulation will give us. So everything that we're working with in product development is managed under the ISO 9001 quality system. So the procedures that we have in place cover the whole process, right from gathering the information to define a new product or project that we're working on, then on into the laboratory where we can put together the formulation to meet the nutrient requirements and any other parameters that we're asked to achieve. Then we'll do the testing for stability, mixability, etc. Once we have promising candidates from the laboratory, we'll then move on into the glass house where we're testing safety and efficacy. And then ultimately on into field trials. So that whole procedure is covered under the ISO 9001 quality system. So each new product that we bring to the market has been through that same stringent test procedure. So by the time we bring a product to the market, we've got a lot of information behind it, and we can be confident about the claims and the recommendations that we're giving for the product. So a lot of the ideas for new products will come in from the market. So if we look back over the last 5 years or so, well over half of the new products that we've introduced have been as a response to someone in the market asking for that new product. So we like to think that we're very market responsive. So the way that the ideas will come into us in the laboratory is in the form of a list of requirements. So obviously we need to know the nutrient or the mix of nutrients that we're dealing with. We need to know the form of the nutrient or the product that we're trying to achieve. So is it a powder, a solution, or a suspension concentrate? Then we need to know how the product is going to be applied. So most of YaraVita products will be folio applied, but we're also producing seed treatment products or fertilizer coating products, etc. And how the product is going to be applied probably has the most bearing on how we go about formulating it. So there are components that we would include in a foliar product that would not be applicable to a seed treatment, for example. Obviously we need to know the crop that we're targeting and the timing of application that is proposed for the new product. One thing that is really critical for the foliar products is for the target crop, for the timing of application that is proposed for the new product, we really need to understand which are the important agrochemicals that are going to be used on the crop at that timing. We appreciate that it is quite rare for the YaraVita product to be sprayed on its own.
It's not really economical for the farmer to do that, so typically he would be tank mixing the YaraVita nutritional product with an ag chem. So it's critical that we know which are those important agrochemicals, and knowing that we can then build in tank mixability during the formulation process. So once we have all that information gathered together to define the product that we're working on, then the first stage in actually developing a new formulation is to consider the raw materials, the basic chemicals that we're going to build this formulation on. So the first part of the demonstration that we have to show you is to try to illustrate the large differences in quality and performance within just one type of chemical raw material. So when we're thinking about raw materials, there are various parameters that we'll take into consideration. So firstly, we're interested in the nutrient content or the elemental content of the raw material. That is going to have a bearing on the nutrient content of the final product. Then, if we're looking to produce a soluble powder or a solution type product, then the solubility of the raw material is really critical. On the other hand, if we're looking to produce a suspension concentrate or flowable product, then rather than the solubility of the raw material, the most important thing that we'll take into consideration is how well it will suspend in water, so suspensibility of the material. And linked very closely to that would be the particle size of the material. And then lastly, very important for the micronutrient materials would be the purity, particularly in relation to the levels of toxic heavy metals. So, as an example, if we were asked to produce a copper suspension concentrate product, then one potential starting material that we might consider using as the basis for the product would be copper oxide. So, we've got 3 different grades of copper oxide to show you. So, copper oxide, like most of the materials we would be using as a basis for the suspension concentrate products, is essentially insoluble in water. So as I go through the demonstration and I mix these grades of copper oxide into the beakers of water, we're not looking for the copper oxide to dissolve. It's not going to dissolve however long I stir the beaker. What we're looking to happen is for it to form a suspension. And this is what is happening when a farmer is using one of the YaraVita suspension concentrates in his spray tank. He's forming a suspension of solid particles. So, first of all, we may identify copper oxide number 1. So this one is black copper oxide or cupric oxide. It contains 77% elemental copper, and visually it looks to be a very fine powder. So you may imagine that this grade will suspend okay in water. But if I take some of this material and mix it into the beaker of water, as I stir the copper oxide, it wets out, disperses, forms a suspension, but as soon as I stop stirring, this grade of copper oxide begins to settle out. So already, I think you will be able to see a lot of the copper oxide already sitting at the bottom of the beaker. Over the next minute or so, all the rest of the copper oxide will settle out and this will just be clear water, and all the copper oxide will be sitting at the bottom of the beaker. So the problem we have with this grade of copper oxide is, even though visually the grade looks a very fine powder, if we were to actually measure the particle size of that grade of copper oxide, we would see that we have a distribution between about 50 to 100 micrometers or microns. So a micron is 1,000th of a millimeter, so it's a small particle, but it is not small enough to stay in suspension for any length of time. And obviously, if this happens, this rate of settlement happens in the grower's spray tank, there's a danger that you're going to block the booms and the spray nozzles. Also, a particle at the top end of that range, 100 microns, is large enough itself to begin to block the filters and the spray nozzles in the sprayer. So all round, that grade of copper oxide would not be suitable to make a YaraVita product from. So we would reject that grade and move on to something possibly more suitable. So next, we may come to copper oxide number 2. So number 2 is red copper oxide or cuprous oxide. So this one has 86% elemental copper. And if we measure the particle size on this grade, we see we have an average of just 2 microns, so much finer than copper oxide number 1. So logically you would think a smaller particle size, this grade should suspend better in the water. But if we take this material and mix it into the beaker of water, what we see is that it doesn't even disperse or wet out, it just forms lumps that sink straight to the bottom of the beaker. And if we can take out one of these lumps, you still see this is just still a dry powder. So the problem we have with this grade of copper oxide is that even though the primary particle size is very, very small, around about average of a couple of microns, the problem is that the surface character of this grade of copper oxide is hydrophobic. So when we put it into the water, rather than the particles separating and dispersing, they just clump together and then sink to the bottom. So for a product that we'd be intending to use in a water-based system, in the farmer's spray tank, this is not going to be suitable. So again, we would reject that and move on to something more suitable. So then we come to copper oxide number 3. So this one is the same chemical as number 2. So it's red copper oxide or cuprous oxide. It has the same copper content, 86% elemental copper, and it has the same particle size, average of a couple of microns. But take this material and mix it into the beaker. What we see with this grade, it wets out, disperses, forms a suspension, and in this case the particles are small enough that they'll stay in suspension for a relatively long period. So in this case we have the combination of the very fine particle size that we need linked to a hydrophilic surface character to the particles. So when they hit the water, the particles wet out, disperse, and then they're small enough to stay in suspension for a relatively long period. The reason for showing this demonstration is that in a lot of markets, because of health and safety regulation or because of fertiliser regulation, we're quite often obliged to disclose on the label or in the safety data sheet the active ingredients in the YaraVita product. And this will sometimes beg the question from the farmer, why should I pay for the YaraVita product? I can buy copper oxide or zinc nitrate or manganese sulfate or any of these other micronutrient materials cheaper than the YaraVita product. So part of our answer to that question would be then, well, not all grades of copper oxide or any of these other micronutrient materials are bound to behave the same. This demonstration shows that within one type of chemical raw material you can get a vast difference between the quality and performance between different grades. So a farmer is not in the position to be able to distinguish between the grades that will work and those that won't. For example, in a written specification, those 2 grades of copper oxide look almost identical. So the copper content is the same, the particle size is the same, the purity is the same, but they behave completely differently. So if the farmer bought that one, then he may be lucky and he gets away with it, but if he buys this one, it's going to block his spray equipment, it's not going to be an efficient treatment onto his crop. So we've been through the process to identify the best raw materials for a particular application. So with the YaraVita product, you can be sure that the product is going to do what we claim it will do. But that's not all. The YaraVita product is a lot more than just the raw materials. So selecting the best raw materials for a particular application is the critical first step. But then on top of that, we also have the formulation, which will enhance the performance of the active ingredients. Also, all the support that is behind the YaraVita product, so the tank mix information, the agronomic trials data, and also the product stewardship. So the YaraVita product is the whole package, not just the raw materials, but selecting the best raw materials for a particular application is the critical first step in making a successful product. Another important factor that we need to consider for raw material selection is purity. And by purity, we're really meaning the levels of toxic heavy metal contaminants in the materials. So this is particularly important for the micronutrient compounds. And this is because in nature, the natural minerals or ores or metals like zinc or manganese or copper are quite often found in association with the ores of toxic metals. So things like lead, cadmium, arsenic, mercury. So if we take zinc as an example, virtually every natural zinc deposit found around the world, you also find cadmium. So there's no avoiding some degree of contamination of the micronutrient metal compounds with these toxic heavy metals. But what we can do by working closely with our suppliers is make sure that the levels of those toxic heavy metal contaminants are as low as practically achievable. So in order to achieve that, here at Pocklington we're using a lot of non-standard fertiliser grade raw materials. So a lot of the materials that we're using here to manufacture YaraVita would be food grade or technical grade, or in certain cases pharmaceutical grade raw materials. So if we take our zinc suspension Zintra as an example, the zinc oxide raw material that we use to manufacture Zintra is pharmaceutical grade. So it's the same material that you might see in cosmetics, or in a mineral supplement for human consumption, or in a cream to apply to a baby. With all of these products, if you look at the ingredients list, you will see zinc oxide pharmaceutical grade, and that is the same material that we're using as the basis for Zintra. And just to show how pure that material is, here we have the grade of zinc oxide that we're using in YaraVita, and on the label we have the limits for the heavy metal contaminants. So we have a maximum limit for 20 parts per million lead, 5 parts per million cadmium, 1 part per million arsenic. So you can see there is some very low levels of these heavy metal contaminants in this high purity zinc oxide, but the levels are very, very low. And just to put that into context, this is another grade of zinc oxide. So this one is an animal feed grade zinc oxide. So it's compliant with the European regulation to allow this to be used in an animal feed supplement. And again on the label we have the limits for the heavy metal contaminants. And in this case we have a limit of 400 parts per million lead, 20 parts per million cadmium, 100 parts per million arsenic. So many times higher than the levels that we have in the grades that we're using in YaraVita. Another example of the high purity materials that we're using in YaraVita would be phosphoric acid. So phosphoric acid is an important raw material in a lot of the solution type liquids, so a lot of the phos products. So Magphos, Senifos, Solatrel, this sort of product are based on phosphoric acid. So the grade that we're using here in Pocklington is white phosphoric acid or food grade, as opposed to the typical green phosphoric acid that would be conventionally used in fertiliser manufacture. And you can see the difference visually between the grade that we're using in YaraVita and the normal fertiliser grade, so far higher purity. So this grade, the one that we're using, the white phosphoric acid, is the same material that might be used in things like Coca-Cola, for example. So the reason we're pushed into using these very high purity raw materials is twofold, really. So on the one hand we have regulations. Fertiliser regulations in different countries will specify limits for heavy metal contaminants, and obviously we need to meet these most stringent regulations in the different countries around the world. But beyond the regulatory side, we also appreciate that there is pressure onto growers to demonstrate to their end users, so to supermarkets or food processing companies, that they have very low levels of residue on their crops, particularly for fruit crops and vegetable crops. So if we can show to the farmer we're using very high purity materials, and we can show our traceability through the production process. That gives the farmer the confidence to use the YaraVita product, knowing he's not going to have an issue with heavy metal residues on his crops. So once we've identified the best raw materials for a particular application, we then come on to the actual formulation process. So by formulation, we mean adding other components, things like wetters, stickers, uptake agents, suspending agents. All these other co-formulants are helping the active ingredient do its job more effectively. So they may improve things like uptake of the nutrient through the leaf, or they might improve crop safety or mixability with agrochemicals, or maybe some aspect of handling the product, so making it easier to pour, stopping it freezing in winter, for example. So we have a whole range of different co-formulants that we use in YaraVita, and we'll just show you one typical example, which is a wetter. So you may remember that pure water has a high surface tension. So the high surface tension of water creates a number of problems if we were to spray an unformulated product onto a crop. So I'm just dripping out some coloured water onto this paper, and the high surface tension is making the droplets contract to an almost spherical shape that sit up on the surface of the paper. And in a similar way, if we were to spray an unformulated product onto a crop, if we imagine this to be the surface of the leaf, the high surface tension of the water makes the droplets that land on that leaf surface contract to this almost spherical shape. So we get discrete droplets sitting up on the leaf surface, like we have on the paper. So what this means, firstly, is that we only have a small surface area through which all the water in that droplet can evaporate from. So this means that drying time is extended. So if there is any adverse weather conditions, such as wind or rain, soon after the farmer sprays his crop, then we can lose a lot of the treatment from the leaf surface. Also, because of the way that the droplet is contracting and sitting up on the leaf surface, we only have this small area of contact between the droplet and the leaf. So all the nutrient in this droplet is focused on one small point of the leaf surface. And this can give rise to phytotoxicity or scorch at the point of contact. Also, we only have this small leaf area through which the nutrient can be absorbed. So it's an inefficient way to deliver the nutrient through the leaf. In a sunny climate, the shape of the droplet can act like a lens and focus sunlight onto the leaf, and we can have a sunburn effect. So all around, these problems are created by the high surface tension of the water. So what we can do in the formulation process to address those issues is incorporate a wetter or surfactant. So I've just add a couple of drops of wetter into this water. Give that a mix. So what the wetter does is lower the surface tension, and that spreads the droplet. So again, if you imagine that to be the surface of the leaf, by including the wetter in the formulation, we lower the surface tension and that spreads the droplet. So immediately we get a larger surface area through which the water can evaporate. So drying time is shortened, and other co-formulants like stickers can take effect, and the treatment becomes rain fast on the leaf surface. Also, we have extended the area of contact between the droplet and the leaf, so we're spreading the concentration of nutrient over a wider leaf area, so we've got less chance of phytotoxicity or scorch at the point of contact. Also, we have this wider leaf area through which the nutrient can be absorbed, so it's a more efficient way to deliver the nutrient through the leaf. We've also broken that lens effect, so less chance of sunburn. So this is one typical example of a co-formulant, the wetter. So here at Pocklington we've got quite a flexible production unit. We're able to make a variety of different types of products. So we have powder products, we have the clear solution type liquid products, and then we have the suspension concentrate or flowable products. So at one extreme are the powders. So we have soluble powders and also wettable powders, some single nutrient powders, and then multi-nutrient powders. So the big advantage of the powder formulations is the concentration of nutrient that we can achieve in this sort of formulation. But the disadvantage, and the reason why over the years there's been a trend away from powders towards liquids, so that now powders only represent maybe 10% of our production volume at Pocklington. The disadvantage of the powders is that they're not so easy or convenient to use. So with a powder formulation, the farmer's having to put a degree of work into dissolving or suspending the powder in the spray tank. He's having to weigh out powder rather than measuring the volume of a liquid. There might be a dust hazard associated with using the powder. So all around, powders, very good for concentration, but not so good for ease of use. So at the other end of the scale, we have the solution type liquids. Again, we have single nutrient liquids and multi-nutrient, quite often crop specific liquids. So with this sort of formulation, the clear liquid solutions, the nutrient is already dissolved in the product. So when it comes to using the product, the farmer is pouring it into his spray tank, he's just diluting something that is already dissolved. So that makes it very easy to use and dilute. Also, with a liquid, he can measure volume rather than weighing out the powder. There's no dust hazard. And if it's a large-scale farm, then he can automate his process because the product is pumpable. So all around, liquid products are far easier, more convenient to use than the powders. But the disadvantage of this technology, the solution liquids, is that the concentration of nutrient that we can achieve in a solution is a lot lower than we can achieve in a powder. We're limited by the solubility of the nutrient sources. So we have to have an appreciable amount of water in the product to dissolve the nutrient, and this limits the concentration that we can achieve. So solution type liquids, good for convenience, but not so good for concentration. So a number of years ago, we came up with the idea of trying to combine the concentration of the powders with the convenience of the traditional solution type liquids. And we did that by introducing the suspension concentrate or flowable products. So now we have a full range of suspension concentrates, again single nutrient suspensions like Zintra, or multi-nutrient, quite often crop specific formulations like ramitril or brasitril. So what we have with this sort of product is a liquid formulation, but rather than being a solution, it's a suspension. So the nutrient in a suspension concentrate is in the form of very small particle-sized solid powder that is held in a water-based suspension. And using this approach, we're not limited by the solubility of the raw material, and that allows us to get a much higher nutrient content in a liquid form. So approaching the concentration of the powder formulations, but with all the convenience of the traditional solution type liquids. But to make these very high concentration stable suspensions requires more sophisticated machinery in the factory, so we need high speed, high shear mixing vessels to create the suspensions, and we also need more sophisticated formulation chemistry. So we'll show you some of the additional co-formulants that we need to manufacture the products like Zintra, for example. So the challenge that we have in making something like Zintra is that the product itself does not contain a lot of water. So just to illustrate that point, here we have half a litre of Zintrac 700, and next to it we have in this cylinder the powder active ingredient, the zinc oxide raw material that goes into that half litre. So the volume of the final liquid product is actually smaller than the volume of the powder active that goes into it. So you can appreciate that in that half litre there is not a lot of water. And just to illustrate that a little further, if we were to mix together the zinc oxide raw material and the water in the same proportion that we have in the final liquid product, then this is the sort of consistency of mixture that we achieve, a real thick paste. And in that condition, not particularly easy to use. So in that mixture, there is less water than there is active ingredient. So obviously the farmer cannot use the product in that form, So to get that into a liquid form, there are two things we could do. We could add more water into the mixture and eventually it will become fluid. But if we add more water, we dilute the concentration, and that's going against what we're trying to achieve. So what we do in the formulation process to make this paste into a liquid but maintain the concentration of nutrient that we're aiming at is to use what we call a dispersing agent. So I'll just add a small amount of dispersing agent into this mixture. And just give this a mix around. So just that small addition of dispersing agent turns the paste into a liquid. So what the dispersing agent is doing is coating the particles, giving the particles a negative charge, and in the concentrated mix the particles then act like magnets of the same polarity and mutually repel, and that allows them to flow against each other and turns the paste into a liquid. But we can't just leave the formulation like that. At that stage in the process the consistency is like water, very low viscosity, and if we leave it like that very quickly the particles in the mixture will just settle out. And with our suspension concentrates we're given a 2-year shelf life. So to achieve that shelf life we need to slow down the settling process, and that requires more formulation. So having made the mixture very, very thin, low viscosity, in order to achieve the stability that we need and the shelf life that we need, we have to increase the viscosity, thicken up the product to suspend the particles. So what we do to achieve that is use a thickening agent. So to illustrate how that works, if we leave the product like I've just made, like water, if you imagine that to be a particle of the zinc in the Zintra, we leave it like water, very, very quickly the particles will just settle out. But by including a thickening agent to increase the viscosity of the mixture, this holds up the particles and slows down that settling process. In the formulation process we can't completely stop the settlement, so this ball is still falling, albeit very, very slowly. So it's normal over the 2-year shelf life of a suspension concentrate that we will get a concentration gradient developed down the pack. So this is a critical difference between a suspension concentrate and a solution. The solution, if the pack is sealed and it's kept in good conditions, it will stay like this indefinitely. Whereas the suspension concentrate, gravity will always pull down the solid particles in the mixture. So it's normal to develop a concentration gradient down the pack. So it's critical that before you use a suspension concentrate, you shake the product, shake the pack. That will return everything back into suspension and also thin out the product and make it easy to pour. So that is a critical difference and a message to get across to the farmer, to shake the pack before you pour it. So with suspension concentrate technology, we achieve a variety of benefits compared to other types of formulation. And one big benefit that we achieve is the concentration of nutrient that we can achieve in a liquid product. So this is an illustration of that point. These 3 tubes contain 3 different types of manganese formulation. So we have Mantrac Pro, our suspension concentrate formulation. We have a solution type liquid based on manganese sulfate, and then we have a chelate powder, manganese EDTA powder. And each of the 3 tubes contains the same amount of elemental manganese. We have 10 grams of manganese in each tube. So with Mantrac Pro we just need 20 millilitres to deliver that 10 grams of manganese. With the solution we need about 3.5 times the volume to give us the same 10 grams of manganese. And with the chelate powder we need about 6 times the volume to give that same 10 grams of manganese. So in the practical situation, what that means with the suspension concentrate product is that we have lower application rates, we have less product to transport or warehouse, and at the end of the process we have less packaging to dispose of. So big benefits compared to other types of formulation. So at the end of the formulation process, what we achieve with the suspension concentrates are liquid formulations, very high nutrient content, which are really easy for the farmer to disperse into his spray tank.
So hopefully that video gives you a bit of a insight into Stuart's genius as a chemist. It's certainly not easy to manufacture these products. So yeah, I hope that's given you an insight. And just to say that this whole webinar has been recorded, so it will be posted on YouTube, so you can watch it back should you so wish. So we've had a few questions come in already, so I'll read them out, Stuart, and you can answer them. So the first one, is purity important during the manufacture of the products?
Yes, absolutely. As we touched on in the demonstration, so particularly with the micronutrient materials, where, as we explained, a lot of the micronutrient metals are mined, and the natural minerals, ores of the metals, like zinc or manganese or copper, can quite often be found in association with the toxic metals like lead, cadmium, arsenic, etc. So it's important for us to source pure raw materials. So the raw materials that we're buying, we only buy from approved suppliers. We have agreed specifications for the materials. We will have stringent limits for contaminants. We measure and test the incoming raw materials before they're used in production, and then we also monitor the purity of the products that are produced in the factory. So throughout the production process, we have traceability and control of purity, and that is really important because from a regulatory point of view, we have to meet all the different regulations around the world, but also we need to give farmers the confidence to use the products, knowing that they're not going to get a problem or a crop rejected by the end user, the supermarket or the food processing company.
Thanks, Stuart. A question more on how the products work. So historically, it has been believed that your products are insoluble in water, so they cannot get into the leaf. Any comment on that?
Yeah, I mean, to the layman, a lot of the materials that we will be using in the YaraVita suspension concentrate products would typically be described as insoluble. But the first thing to note is that none of these are completely insoluble. So it's more accurate to describe them as low solubility or sparingly soluble materials, so things like oxides, carbonates, hydroxides, etc. So all of the YaraVita suspension concentrates already have a small proportion of the nutrient in a soluble form. So when that deposit lands on the leaf surface, there is some soluble nutrient that's ready to be taken up immediately by the plant. But that's not the end of the story. The leaf surface is not inert. So typically a leaf surface is slightly acidic due to the organic acids that the plant exudes onto the surface of the leaf. There's also a lot of microbial activity on the leaf, and all these things facilitate the digestion or the dissolving of the particle on the leaf surface, and that again solubilizes the particle and facilitates uptake through the leaf. And if we manage the particle size correctly, and a lot of the technology on the suspension concentrates is to do with achieving the optimum particle size. If that is correct, then the speed with which the nutrient is released into the plant is controlled, and we will achieve the uptake that we want in the timing that we want. But ultimately, we've got thousands of trials that demonstrate that the materials that we're using in the suspension concentrates are plant available. So we spray onto a leaf, and we can measure uptake into the leaf and an uplift in the nutrient status in new leaf growth. So leaves that weren't, or parts of the plant that weren't sprayed with the formulation will show an uplift in nutrient status, demonstrating that the nutrient has been absorbed and then translocated within the plant. So that's a clear demonstration that the materials, although generally would be considered as being insoluble, they are plant available.
Okay, thank you. So following on from that, another one is, how does the performance of suspension concentrates compared to sulfates and nitrates?
There's no doubt there's a difference in the uptake profile of a suspension concentrate compared to a simple inorganic salt like a sulfate or a nitrate. So as we've described, there's a controlled release of the nutrient with the suspension concentrate. So what we achieve is a longer process of release of the nutrient over a longer period. But that gives benefits in terms of crop safety, so we're not overloading and getting an immediate spike, high concentration of nutrient in the localized area where the product has been sprayed. So that makes the treatment safer, less chance of scorch. And we also get this long-term feeding action, so we can feed the crop over a number of weeks. So that the uptake profile is definitely different. But also we have other benefits. So tank mixability is generally, we get wider tank mix profile with the suspension concentrates because we're not dissolving the nutrient in the spray solution. So we don't have free zinc or manganese ions in the tank mix that are ready to react with the ag chems in the tank mix, as opposed to a fully soluble sulfate or nitrate where you can get interaction and incompatibility. So you get a benefit in that way as well.
Perfect. So yeah, again, another one that sort of follows straight on from that is, how can I check if your products will mix in the spray tank?
Well, for those who are not aware, we offer a tank mix service. So we have a website, tankmix.com, where anyone can go on and search for tank mix partners. So any YaraVita product with any number of ag chems will have been tested. So we've got a massive database on the website, over 30,000 test results that are there freely available to anyone who wants to go on and search. If you can't find the particular mix that you're interested in, then you can request us to carry out a mix, and we can we receive that either via the web request or via email or a phone call even. We'll carry out the test and come back with an answer. Our tank mix service is just giving a judgment on physical mixability. We have no judgment about biological compatibility. All we're saying is whether you mixed these two or more products in a tank mix, whether those will be sprayable. So it's a simple black and white answer, a tick or a cross. Yes, it's tank mixable. No, do not mix these products. It'll be incompatible.
Yeah, thanks. So just on that, we will be relaunching the Tank Mix website shortly and hoping to have a new app this year. So keep your eyes peeled for that on social media, because when we'll have a full relaunch, because it is a vital service we offer for the YaraVita products is tank mixability, and it's one area we know why people choose our products over competitors is the tank mix profile. Certainly as we get more complex tank mixes going on farm. So yeah, keep your eye out for that one. A couple more for you, Stuart. How should we handle our suspension concentrates on farm for best practice?
Yeah, as we touched on again in the formulation demonstration, suspension concentrates, with all the formulation that we put into them, we give a 2-year shelf life, but it is completely natural within that 2-year shelf life that you will develop a concentration gradient down the pack of a suspension concentrate. That is the natural behavior of this sort of product. So it is critical that you shake the pack before you open it and pour it into the tank. And by shaking the pack, you return everything back into suspension, and also you thin out the product and make it easier to pour. So shaking a suspension concentrate is really critical.
Yeah, and as you would have seen from the demo, that the amount of water in some of these products is very small, which is why they weigh so much. So yeah, just from a practical point of view, as somebody that sits on a sprayer myself, you know, I often find just turning the boxes upside down, yeah, even when I've mixed one tank load up on the sprayer, get the next load of boxes turned upside down before heading off to the field to get rid of that tank full. And I personally do that for all suspensions, not just ours, for other ones as well, whether it be fungicides, herbicides, whatever. Stuart, how long does it take to develop a brand new product from scratch if somebody came up with an idea today?
It's quite variable, actually. I mean, typically I would say probably the normal length of time it would take from start to finish is typically around about a year. But if we're looking at just a very simple variation on a theme, so it's known technology, and we just maybe slightly varying the proportions of nutrients in a product, then the absolute minimum we could turn a new product round might be 3 months. Within that time, we can carry out the storage stability testing that is necessary and a basic crop safety assessment. But that's unusual. So more typically it'd be a year to do a new product. And more recently, when we've been looking more at the biostimulant developments, they are taking longer because we're having to test the concept of the biostimulant activity. So some of the development projects that have recently come to fruition on biostimulants have taken 4 years from start to finish.
Thanks, Stuart. Another one just come in. How do you ensure the rain fastness of our YaraVita products?
So rain fastness is particularly important for the suspension concentrates because we're wanting the spray deposit, the particles, to stay on the leaf surface for a relatively long period. If they wash off the surface, we're having the long-term feeding action potential that we have with the suspension concentrates is meaningless if it's just going to wash off. So we do need to stick the particles onto the leaf and stop them being washed off. So to enable us to do that, we have various stickers in the formulations. So there's various materials that we use. It varies from formulation to formulation that essentially glue the particles onto the leaf surface and prevent them being washed off easily.
Excellent, thank you. Final question, because it's come in just coming around sap and tissue testing. So yeah, which is the most effective method, sap or tissue testing? So I'm happy to answer that one. I think they both have a place. I think whatever you do is, if you're going to go to the trouble of tissue testing or sap testing, then do something about the result. I think with anything, when you do a testing, it's the data interpretation that makes it stand out. You know, and I think one thing that has happened in the last few years has been a big project on benchmarking nutrition, moving away from the old guidelines to what's right at each point in time. And we'll cover that more in our next webinar. So I hope that's given you some insight into how we manufacture the products and what goes into them. We will be hosting another webinar on the Monday the 27th of February. That's needed a reminder, at 7 p.m. That'll be a live webinar, and within that webinar we'll move away from the products and go more into the agronomy side of it, and we'll look at how we can optimize our arable yields and profitability with foliar fertilizers. So the next session will be very much an agronomic session. There will be basis points available for the next session because it's obviously agronomy based, whereas this wasn't. This was very much looking at the actual products. So the next session will be very much looking at in-field agronomy, what we can do to optimize. Basis points will be available. So please, again, keep your eye out for that. We will, as we've said, this is recorded and we'll post it on our YouTube channel. What I would say to anybody is subscribe to the YouTube channel, subscribe to the Yara newsletters, keep your eye on all our social media, because we share a lot of information on there. Even things with some of the questions have come up today about handling products. I unfortunately had to put a white suit on and look like a Michelin man, but we did a good video of practically how to use the products on farm. So there is a lot of information out there on our various social media platforms. Thanks for joining us this morning. I don't know with everyone else, but here in Lincolnshire, it's a fantastic day. There's not a cloud in the sky. So I'm sure people want to get out into the fields, and land work is happening. So yeah, do it safely. Thanks for your attention today, and particular thanks to Stuart for giving his time up, for joining us. Hope you found it useful, and we'll see you all again on Monday the 27th of February at 7 p.m. for a session on the agronomic merits of YaraVita products. Thanks all, and thanks Stuart.
Thank you.